Taking a break from radians. Here's the thing. This is a long unit. And to be successful in the second half of the unit, after we take the quiz, you got to remember some stuff from your sophomore days in geometry. However brutal they may have been. Okay, because that's back in the day when you guys used to come to school for a day off. So maybe some of you stayed home the full time because you were virtual, but we need to be good in some of those topics to be able to succeed in the second half of the unit. So today's going to be Pythagorean theorem. Tomorrow's going to be sine, cosine, tangent, SOHCAHTOA. We got to review those two concepts if we're going to be successful in the second half of the unit. So let's go right now. Pythagorean theorem. Let's jump right in. Throw anything you remember at me. Pythagorean theorem.
A plus B equals C.
You're missing something there. Missing something on the A, B, and the C.
A squared plus B squared equals C squared.
Here we go, everyone. A squared plus B squared equals C squared. It can only be used, though, one in one situation only. The triangle you are working with has to be a right triangle. All right, what are these two sides that form the right angle? Anybody remember what they were called? That form the right angle? Well, it hasn't been that long. Legs? Anybody? Legs? Yes? Okay. That's your A and your B. A and B are called your legs. That's where they form the right angle. And the other side across from the right angle is always the hypotenuse. That's the C value. All right. So those are the values we plug in. The two legs squared equal the hypotenuse squared. Draw part A for me. Here we go. Letter A. Right triangle ABC. C is your right angle. A and B can go anywhere, but C's got to be the right angle. AC is 2, BC is 3. Find what AB is in simplest radical form. You're dealing with the right triangle. You're dealing with not only are you dealing with the right triangle, you're dealing with all three sides of a right triangle. That automatically equals Pythag if you're dealing with all three sides. All right, turn it over to you guys. What you going for A and B here? 15, what are the two leg measurements? No, all right. 11, what are the two leg measurements?
2 squared and 3 squared.
So 2 squared plus 3 squared, they can go in any order, equals C squared. I am not going to assume you know how to solve this. So I'm going to take my time. I get 4 and 9 equals C squared. Do I add these two together or take the square root right now? Add 4 and 9 or take the square root of each? I'm not assuming anything. Got to add them together. Add them together first. C squared equals 13. Once it's now all complete, at the very end, you take the square root. Don't bother touching your calculator because the directions say simplest radical form. So leave it square root of 13. I don't want the decimal. Simplest radical form, 13. Questions? All right, let's move on. Other ways I can use Pythag. We got good old Laura here. It looks like we got a landscaper on her hands. She's got a rectangular garden, 12 by 15. All right, draw a simple rectangle. One side's 12, one side's 15. It's not going to matter which is which. Oh, she wants to put some rocks on the diagonal. What's diagonal again? Where's the diagonal on this rectangle? Up and down.
Corner to corner.
Oh,
diagonal.
That's embarrassing. Yeah.
Diagonal.
Corner to corner.
We'll just pretend we didn't hear that.
No, you didn't.
Yep, corner to corner. Hold on though. I told you guys Pythag can only be used on a right triangle. Where's this right triangle?
Bottom right.
What type of figure is this?
Rectangle.
So all rectangles have right angles from your geometry days. And find the length of the walkway. All right, now I can use Pythag. I got a right triangle, all three sides. All right, what are the two legs in this case? 8, what are my two legs here?
12 and 15.
Okay, 12 squared plus 15 squared equals C squared. 369 equals C. I got to add them first again. 369 equals C squared. Now you can take the square root, read the directions. I don't need simplest radical form. I need nearest tenth of a foot. So take the square root. Hey, I was surprised to know a couple people didn't know where the square root button was on the calculator. Everyone find it? A couple people didn't know last period, so I can't assume that. And to the nearest tenth of a foot. When you have it, let me know. 14, nearest tenth.
19.2.
19.2 feet. Good. All good? Okay, those are two basic ways to use it. We need to use it a little bit more advanced, though. So take a look at my right triangle now. Find the value of x. All right, so I see it's a right triangle. I know something about all three sides. So I get out my Pythagorean theorem. What are the two legs on this diagram? What are the two legs? 13, two legs? No, 13. 9, what are the two legs?
8 and x minus 4.
So 8 squared. Now how do I write this x minus 4? X minus 4 squared. That's how I write it. That leg squared, and then the hypotenuse is x, and I square it. All right, before we start getting nuts, we all know 8 squared is 64. Now how do we deal with this here? X minus 4. Hey, it's not this. Get out of here. Get out of here. That's garbage. Garbage. When you square something, you multiply it by itself twice. So off to the side, we got to do x minus 4 and x minus 4. Double distribute. I'll give you guys a minute to do that. Now somebody's going to tell me what they ended up with. Squaring means multiplying it by itself twice.
Did you square?
Double distribute. Distribute the x, then distribute the negative 4. Combine like terms if you can. 6, when you're ready here, what do we get when I x minus 4 and x minus 4?
X squared minus 8x plus 16.
Good job. X squared minus 8x plus 16 equals x squared. Let's clean it up a little bit on the left because I see 64 and 16 I could combine. X squared minus 8x plus 80 equals x squared. So I add the 64 and the 16. All right, what's your deal now? What's your next move here, algebra kids? Got to solve for x, right? Any thoughts? Yeah, Dylan, go ahead.
Not what's it called? Not the quadratic formula.
Oh, please no. Please
I
don't
don't-
bring that up.
What, the quadratic formula?
Yeah, you're going to make people go nuts.
For some reason I do not remember what it's called, but something like but the stuff we were doing earlier. in the
Factor.
year. Factoring. Yes, that's what I'm looking for.
Good. You see an x squared, so you had to factor, right?
Yeah.
Good news is you're not going to have to do that
Oh,
here.
okay.
Oh, here's why though. He saw x squared, so he's like probably going to have to do a little factoring, but you can't factor unless one side's equal to what? 0, right? And watch what happens. If I move this x squared over, which I want to, what's going to happen? What's going to happen over here? I move this x squared over by subtracting it. What's going to happen to the x squareds? They are going to cancel each other out. And I'm going to be left with negative 8x plus 80. And what on the right side? Can't leave it blank. $15, yep. 3, what am I left with on the right side? Okay,
What number did you say?
3.
Oh, sorry. What's Jeff's question again? Negative
8x plus 80 equals,
0.
yeah. So you don't need to factor. Solve it now. Go ahead. Solve that for x. And your value of x when you get it? 9.
Negative 9.9.
All right, so how are we solving this for x?
So you minus 8.
Okay. Minus
Oh.
8?
Minus 80. I
Okay.
put a 1 there. That's my bad.
Minus 80. Go ahead, fix it.
And then it'd be negative 80. And then you do 80 divided by negative 8.
Negative 80 divided
Negative
by
80
Yep.
divided by negative 8, which would be 10.
Good deal. All right, there's Pythag. Any issues? Pythagorean theorem. All right, last concept from your sophomore days. Special right triangles. And this might be, maybe you never even did it. Some people remembered it, some people didn't last period. Special right triangle. So draw yourself a right triangle for me so I can introduce the first the special right triangle to you. The first one I'm going to introduce is when the other two angles are both 45. I don't know, familiar? 45, 45, 90? Maybe? What are these sides called again? Legs, right? And do you guys notice that they're both across from what angle? Both legs are across from what angle measure? I'll keep going to it, no big deal. 12. Both legs are across from what angle measure? No 12 either? It's amazing how everyone's here but one person. 8. The legs are across from what angle measure? The 45s, right? Somebody's just not speaking up, so we'll just do numbers over again. That's not a big deal. It's across from the 45s, which means legs are equal. In a 45, 45, 90, both those sides are equal. So that just leaves us, how do you find the hypotenuse then? How do you find the hypotenuse in a 45, 45, 90? No issues. You take one of the legs. Ready? You take one of the legs. Doesn't matter which one you pick. No, because they're both equal. And you multiply it by, anybody remember that one back in the day? Show off.
1.5. No.
Square root of 2. You multiply one of those legs by the square root of 2, and you have the hypotenuse. So don't write this down real quick. Let's say this side's 8. What are the other two sides then? What's the other leg? 8. And now without doing Pythagorean theorem, what's the hypotenuse? No, just don't, no decimals. Just put them together. 8 times. That's it. Okay? So that's how that works. Legs are both equal. Hypotenuse, whatever the leg is, multiply it by radical 2 and leave it. I don't want a decimal. Good? Because the other one's a little more complicated. All right, the other special right triangle we got to talk about. Anybody remember this one? What the other two angles were? 30. Well, I already got the 90. Good, yep. 30, 60, 90. Do you think the two legs are equal here? No, because they're across from two different degree measures. But there is a shorter leg and a longer leg here. How do you remember from your geometry days how you can tell which side is longer than the other? Longest side is across from the larger angle. Smallest side is across from the smallest angle in every triangle. So where's my shorter leg going to be? Across from? Where's my shorter leg going to be? Across from? Okay, so let's just label this shorter leg. And across from the 60 will be my longer leg. And then the other one's the hypotenuse. So here you go. Here are the two rules we got to remember. First rule. Is everyone all right if I abbreviate longer leg LL? The longer leg is equal to whatever the shorter leg is times square root of 3. That's one thing we're going to have to work on, keeping those separate. The shorter leg times radical 3. And the hypotenuse, that's equal to the shorter leg times 2. Double the shorter leg. Real quick, ready? Nick, just give me a side length here. Just give me a number for a side length. 9. Here you go, everyone. That side's 9. How can I find the other sides?
9 times.
You want to start with the hypotenuse? How long is the hypotenuse if that's 9? The shorter leg, 9. 18. And then what about the longer leg then? If the shorter leg is 9, how do you find the longer leg? 9 times square root of 3. There you go. Part A, draw the triangle for me. Go ahead, draw your triangle. Make sure your right angle's at C, like it says. First thing, it's a 30, 60, 90, right? 30, 60, 90. Second thing, what is 8? Is that the shorter leg, the longer leg, or the hypotenuse in this diagram? Shorter, longer, or hypotenuse? What's the 8 represent? 9?
Longer.
Where's it?
Shorter.
Why? Because it's across from
30.
the 30. Makes it the shorter. I'm looking for AB, which is the what in the diagram? What's AB in the diagram? 13? Tomorrow. 7? What's AB represent?
AB.
Shorter leg, longer leg, or the hypotenuse?
The long, shorter leg.
We already have the shorter leg, Tim. It's across from the 30. What is AB in the diagram? Hypotenuse. So what do I do to the shorter leg to get to the hypotenuse according to my rules here? How do I find the hypotenuse? 13, 14. How do I find the hypotenuse?
Do shorter leg times 2.
So what's my shorter leg, Jared?
8
Times?
times 2 is 16.
There you go. Double the shorter leg. And again, how do I know that's the shorter leg? Where's it across from? 30. Shorter leg is always across from the 30 because it's the smaller angle. Hey, a little ladder leaning up against the wall at a 45-degree angle. So let's just get our right triangle down. Our ladder leaning up against the wall at a 45-degree angle. So the ladder and the wall form a 45-degree angle. Where do I put the 12 feet? The ladder's 12 feet long. Where should that go? On one of the legs or the hypotenuse? Dylan?
Or I had a question.
Yeah, go ahead.
Earlier.
Yep.
So like at the top, like when you put like the 30 and the 60 and like the 45 and 45, those were leg lengths, right?
Correct.
Not angles.
45 and 45 are degree measures.
Oh, they are.
Those are angle measures.
Okay.
Correct.
All right. I don't know. I mean, you're putting them in a spot that made them be like angle measures, but I don't know.
Yeah.
I just thought that. They weren't.
No, those are all angle measures.
Yeah.
Okay. Okay, back to my question. Where's the 12 go? The ladder leaning against a building is 12 feet. Should I put the 12 on one of the legs or the hypotenuse?
Hypotenuse.
Thank you, hypotenuse. And we're looking for how far up the wall does the ladder reach. Is your wall vertical or horizontal here? Yeah, this is what we're finding. Yep. All right, so this is a 45, 45, 90, right? This is a 45, 45, 90. What is the 12? Hypotenuse or leg? 14, 12, hypotenuse or leg?
That's how you top.
Hypotenuse. What's the x? What side are we trying to find? 14 again.
We're trying to find the
What's that called? Well, you already told me 12 is the hypotenuse, so that's got to make x what?
shorter.
Well, there in a 40. Remember, in a
No, that's what I
45,
was thinking.
in a 45, 45, there is no shorter or longer.
Yeah,
Why?
they're all equal.
Because they're both equal. So just it's a leg.
Oh.
That's it. It's a leg. Okay, they're both equal. So let's get out the rule I gave you. Hypotenuse equals what? How do you find the hypotenuse in a 45, 45? Reread the rule to me. 12. Reread the rule. Thank you. Leg times square root of 2. Help me fill it in now. Fill in that rule for me. 5. What's the hypotenuse?
12.
12. Equals leg x times radical 2. All right, how do I get the radical 2 out of there? It's x times radical 2. So how do you think I get the radical 2 out of there to solve for x? 8.
Square? Wait, no. Divide?
Divide, right? Yeah. If it's being multiplied, undo it by division. Oh, put them down. Simplest radical form, no decimals here. So we need to take a trip down self-respect lane. All right, self-respect lane. I know you did it. You just got to dig deep and remember. Probably even you did it last year. You are not allowed to have a radical in the denominator of your final answer. This is not acceptable. It's correct answer, but not acceptable. Anybody know why?
Because we need to multiply. We need to multiply by the square root of 2.
When you have a radical in the denominator, to get rid of it, this is what Tim just said. You multiply the top and the bottom by that radical. Maybe dusting off the cobwebs a little bit. You cannot have a radical. You'll hear me all year long say self-respect. And that means, hey, get that radical out of the denominator by multiplying top and bottom by it. All right, what happens? X equals, what do I am left with on top? Stop with the decimals. Stop.
12.
Just 12 and
Radical.
yeah, that's it. Stop with the decimals. And what do I get on? Anybody remember this trick? A radical times itself? No, not 1. Try it out on your calculator. Radical 2 times radical 2. Anytime you multiply a radical by itself.
Oh, it's the same.
You get the number underneath the radical, right? You get the number underneath. So over 2. And I'd really love to go to the next problem, but we're still not simplified enough. Anybody want to take a stab at why we're not?
Because you can do 12 divided by 2.
Darn right we can. So my final answer will be 6 radical 2. That's going to happen a lot this unit. You get a radical in the denominator. And with the 5 minutes we have left, we're going to finish this problem. Label everything you can right now. Go ahead, label your diagram with all the directions. Fill in your angle measurements. We'll find everything together. I just want you to fill everything in. So put the 10 on BC, 45 degrees and 30 degrees labeled. Do you see a special right triangle here? One we've talked about. Name one of the special right triangles you see in the diagram. 12. Name one of the special right triangles you see. BCA. BCA is the big one. And that's got a 30 degree in it. Okay, BCD is a 45-45. Good. Everyone agree? BCD, 45-45. What's the 10? Is that a hypotenuse or a leg of this 45-45? Leg or hypotenuse? 8. Leg or hypotenuse? Leg. So that means if I'm dealing with a 45-45, oh, one leg's 10? What are you going to tell me about the other leg? 15? Stealing my fire. 10? If one leg's 10, what's the other one? 10. They're all equal. Name that leg.
The shorter leg.
No. Name that leg that's 10 using the letters on the
CA.
C. Where's this? Here's your 45-45.
Oh, CD.
CD. Ready? CD equals 10. Got it. Both legs are 10. Reread the rule. How do you find the hypotenuse in a 45-45 90? 6. How do I find the hypotenuse? Times, well, you better look back, not times 2, times square root of 2. So, Ryan, what is the hypotenuse in this? Name the hypotenuse with letters now. Is it CA, CD? Where's the hypotenuse in the 45-45 here? BD. So, BD is going to be leg 10 times, what'd you multiply it by? There you go. Done. Leave it. I don't want the decimal. All right. So that took care of the 45-45 90. Anybody see another special right triangle other than the 45-45? There should be. There should be. 1. 3 numbers. No people. 4. 30-60-90. Everyone see the big one. Let me draw it out for you. Make it easier. Let's draw this out. The big one. B, C, A. This is 30, right? A is 30. We already know this is 10. So this must be 60. What is the 30? What's the 10? Shorter, longer, or hypotenuse? Shorter, longer leg, or the hypotenuse? What's the 10? 13? Mind me tomorrow. It's all funny until people are just not even saying a word. 12. Is the 10 the shorter, longer, or the hypotenuse? Shorter. Shorter. So look at your rules. How do I find the longer leg up here then? I know the shorter is 10. How do we find the longer leg in a 30-60-90? 5? That's how you find the hypotenuse. So we can do that. Clayton, what's the hypotenuse on this diagram? 20, which is what side? BA is 20. And I'm going to run out of time here. I'm CA. I multiply the shorter leg times radical 3. 10 radical 3. I'll give you time on delta math. About 15 minutes tomorrow on delta math.